Welcome to clickmyproject.com. Our project title is Energy Efficient Clustering Using Correlation and Random Update Based on Data Change Rate for Wireless Sensor Networks. Our project abstract is Energy Efficient Clustering Method Using Random Update for Wireless Sensor Networks. These clusters are then updated by applying a dynamic update policy and a cluster head rotation scheme, where the change of sensor data and the energy residue of sensors are taken into consideration to achieve a high energy balance. The larger change rate of sensor data in a cluster, the higher its update frequency. A sensor node that has a high data frequency is more likely to be selected as a head of its cluster. In the data transmission phase, a sampling rate control method is adapted to improve the efficiency of data sampling. The experimental results indicate that the proposed EECRU method achieves high energy efficiency and energy balance. Our project data flow diagram is, we have to randomly sense the data from the cluster head. First we have to deploy the nodes. On that nodes we have to randomly select one cluster head by using cluster formation phase. Next we have to select the one node to update the information randomly to cluster head. In that cluster update by using EECRU algorithm. The two methods are followed by the cluster update method. First one is dynamic update policy and second one is cluster head rotation. In dynamic update policy is to update the information dynamically. In cluster head rotation, each node has a cluster head to getting the information to cluster heads. After update method, we have to transfer the information to destination by using sensor. In that transmission by using sampling rate control method. Finally we calculate the experimental result. In MATLAB file we can run the source code from command window. In left corner the current folder will be shown. It is on our source code file. In that file we can select main.m. In main.m file is our source code file. We have to run the main.m file. It is the number of nodes will be 54, so the cluster head can 54 times to act as the cluster head. It is our graph. It is on cluster formation. In that cluster formation the number of nodes will be shown. In that number of nodes we can select any one. Is randomly we have to select one cluster head. It is a cluster head. In that cluster formation it is a cluster head. In that cluster it is a cluster head. The each node will be act as a cluster head. It is automatically or randomly to update our information to the cluster head. Finally the information to collect the cluster head to send the destination in workspace will show on the value of our update methods. It is shown on the number of alive nodes and alive nodes present in the cluster head, the cluster's throughput, the dead nodes, the energy of the cluster head, packet length to base station to receiver, the residual energy, throughput, the total energy. We can calculate the total energy of the cluster formation. Finally we calculate our energy graph between energy and number of nodes. The number of nodes will be shown in the X label and energy will be shown on the Y labels. It is our proposed method. In this graph shown on the alive nodes, the X label will be shown on time, the Y label will be shown on the number of alive nodes. The cluster formation method to transfer the energy from the cluster head, it is on randomly to sense the data. So how much time taken to deliver the information from node to cluster head, it is the graph for the number of alive nodes. Finally we have to compare our residual energy. In X label we have shown the total energy, the Y label shown the residual energy. It is our proposed method for residual energy for random update method. Thank you for watching.